In the previous video clips, I explained some generalization technique for neural networks, but most powerful technique for generalization is increasing data size. Collect more data. When you have billions of training data points, you can easily train millions of parameters with very small generalization. When you increase data size, there's no cons. There's always benefit. Okay? So, to improve your performance, the most powerful way is collecting more data and labeling more and more. But the problem is, in practice, we don't have such nice data. We always have a limited number of data points, and the main reason why we always have very limited data is labeling data always costs. Okay, someone should label input and output pair manually. This is very dirty job. No one wants to do labeling images, labeling video clips millions times without paying anything. Okay, so this is main bottleneck for having very nice performance. So that's why many people have to invent some generalization technique to have better test error or test accuracy. So some people try to attack this problem more directly using data augmentation technique. So data augmentation technique basically virtually increase the number of data points using very cute, simple trick. So the trick is very simple. For instance, if you have many data points, ImageNet data, so there are some car, some flowers, and so on, and the data point, each data point has assigned to some specific label, like ImageNet data set. You can increase the number of data points using very simple technique: horizontal flip, random crops and scale, color jitter. Because although you flip your image, the car is just car, flower is flower. Horizontal flipping does not change the objective label. Even if you flip your car image, it's still car. But in pixel-wise, for machine, the two image, original image and flipped image, they have totally different pixel value. Okay? So when you train original image and flipped image, although you use almost identical image for human, but it is definitely very useful for training machine, because machine understand image from some digital number assigned to each pixel position, and if the pixel value becomes totally different For machine, this is totally different image. And for such flipping, we can keep the same label always. So basically from horizontal flip, we can make the input data points size double, right? Random crops and scale as well. Even if you stretch and rotating a little bit your input original image, you can keep the output label. Rotating car is still car. Scaling car is still car. Scaling cat, still cat, and so on. Color jittering as well. So this kind of simple, flipping, cropping, jittering operation just can simply increase the number of data points, and such operation improve the test accuracy. You can simply decrease the generalization gap by adding such flipped image, randomly cropped image, color jittered image, and so on. So this is very basic data augmentation technique. And from this idea, very recent paper called mix-up algorithm invent this data augmentation technique. So take two input data xi, xj randomly and set random value alpha and 1 minus alpha here, and just add two input to make a new input x prime. This is totally new input data point. But we don't know the label because this is totally new. This is kind of mix of two existing input data. For this newly generated data, we assign label from yi and yj with the same weight alpha and 1 minus alpha here, y prime. So this is new data point pair x prime and y prime. Using this rule, you can generate a lot of new data point using very simple operation. Just take random 2-point data point and take some kind of a weighted average, alpha weight to xi and 1 minus alpha weight to xj, and the output label as well. Okay, so this is very strange for human, right? So this is kind of take a car image, take some boat image, and just add two image and assign label half car, half boat. Okay, we don't use such image to train your baby to understand pictures and the word. But for machine, this is very useful. It turns out that mix-up algorithm can improve the test accuracy very efficiently. After mix-up, conmix algorithm also invented. This also very efficient algorithm. Conmix algorithm basically cut your image 1 and cut image 2 and combine this area and this area to make a new image and so on. Right? Okay, so this kind of very artificial data augmentation technique also very useful for training your neural network, and you can expect kind of increasing number of data points. Okay.